Hello students, this is Mrs. Jennifer De Cruz from Lilavati, Lalji, Dayal High School and College of Commerce. And in today's Science 1 class, students, we shall study chapter number 6, Refraction of Light. So before starting with this interesting chapter, students, let me tell you all that the total weightage of this chapter is 7 marks with option and 5 marks without option. So let's begin with this interesting chapter. So students, before starting with the chapter, I will tell you all that in this chapter, we shall cover up the following topics. First, refraction of light. Second, the laws of refraction. Third, refractive index. And fourth, dispersion of light. So let's begin with the first topic, that is refraction of light. So students in the lower classes, okay, we've already studied that light, it travels in a straight line. And because of this, if an opaque object lies in its path, a shadow of that object is formed, okay? And we've also learned how these shadows change due to the change in relative positions of the sources of light and the object as well. So students, the light, okay, the change in the direction of propagation of light as it passes from one transparent medium to another is termed as refraction of light, okay? So this refraction occurs as the velocity of light is different at different mediums, okay? So the velocity of light, students, can't be, the same all the time. So here, due to the interaction between the light and the particles of medium, the velocity of light is never the same. So what is refraction of light, students, in simple terms? When light changes its direction, when going from one transparent medium to another transparent medium, it is called as refraction of light. Let's move on to the next topic, students, that is the laws of refraction. So students, herein we have two laws of refraction. First, the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incident all lie in the same plane. Second law says that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant, okay, for the light of a given color and for the given pair of media. And this law, students, is known as the law of refraction. So if I is the angle of incidence and R is the angle of refraction, then sine I upon sine R gives you the constant, okay? That is also termed as the Snell's law, okay? The constant, which is always denoted as N, is always considered as the constant. Let's move on to the next topic, students, and that is, the refractive index. So students, the refractive index depends on the velocity of light in the medium. So as I told you, if I is the angle of incidence and R is the angle of refraction, then sin I upon sin R is equal to the constant, okay, which is the Snell's law. So this constant is called as the refractive index, okay, of the second medium with respect to the first medium, and it is denoted by N21, okay? And then students, if V1 is the velocity of light in the first medium and V2 is the velocity of light in the second medium, then N21, that is the refractive index, is equal to V1 upon V2. Similarly, students, if the refractive index of the first medium, okay, with respect to the second medium is given by N12, okay, which is equal to V2 upon V1, okay. So if the first medium is vacuum, then N21 is considered with respect to vacuum. It is called as the absolute refractive index of the medium, and it is denoted by N. And students, the medium of index of a medium, it depends upon the magnitude of the velocity of light in the medium. So N21 is equal to V1 upon V2 and N12 is equal to V2 upon V1. Okay. So what is V1? The speed of light in medium 1 and V2 is the speed of light in medium 2. So let's move on to the next topic, and that is dispersion of light. So students, what is dispersion of light? The process of separation of light into its component colors while passing through a medium is termed as dispersion of light. So students, the band of color components of a light beam is called as a spectrum. Okay. And the different colors of light in the spectrum of white light, okay, you can see in the diagram below. Okay. We have the orange color, white, indigo, blue, green, and red. So it is found that in dispersion, the ray corresponding to the violet color deviates the most and red color deviates the least. So the deviation of rays corresponding to other colors is intermediate. That is when sunlight, the white light, okay, which is there, is incident on a prism, then the dispersion of light takes place, forming a spectrum, which you can see in the diagram that is given below. Let's move on to the next topic, students, that is partial and total internal reflection. So students, when light, okay, it travels from one medium to another, the part of incident light comes back into the first medium. And this is termed as partial reflection. Okay. So the remaining part is the refracted part. Then students, when light travels from a denser medium to a rarer medium, the angle of refraction R is greater than the angle of incidence I. So the ratio, that is sin I upon sin R, okay, is constant for a particular value of I, and R becomes 90 degree. So students, this particular angle of incidence is termed as the critical angle, okay, which you can see in the diagram. So students, if I is greater than the critical angle, as R cannot be greater than 90 degree, then the light is totally reflected in the denser medium. And this is called as the internal reflection. Hence, N21 is equal to sin I upon sin 90. Okay, wherein you get, sin I, wherein I is the critical angle. Okay, so this is what partial and total internal reflection is all about. So students, with this, we've completed the chapter. Thank you.